Okay, I accidentally pressed stop on the video, but I guess this will be part two if I can't figure out how to join those two videos together. So yeah, I accidentally pressed stop instead of continue. So anyways, we're back to here, and we've subbed in the values. You see we have this A as 36 over here. The sine of B, 48, is over here. The sine of A, 107, is over here. And what you do from this point is you just enter it into your calculator. As simple as that. And I will do that off screen and try not to make a part 3. Okay, so here I have the equation in my calculator. You see we have the 36 times the sine of 48. And this bracket at the end of 48 is very important, or else it will divide 48 by the sine of 107, which is not what you want. And so then we have here, you can just see we divide by the sine of 107. And the answer that we get is, let's round that to 28 centimeters. Because this is a side length, we'll have B equals 28 centimeters. And so that is the length of B right here, is 28 centimeters. Now, we can use this to solve sides, but mainly in physics, we will be using the sine law to solve angles. But, I mean, sometimes it is good to solve sides, but we need it for angles. Now, let's just take this triangle back, and let's erase this 25-degree value, okay? And then, this C, I don't know what to... Okay, hold on. I'll go off camera and then fix this up. Okay, I fixed it up. I erased the value for B because it's not really needed in this situation, and the value of B over here also not needed. And so we can see over here that we can use the sine law because we have the side and angle pair, as well as another value. And so now we're going to be solving for the angle C, which I have named theta because why not? And so how we do this is we will go over to our equation that I will transport us over to. Okay, this is our equation. Now, this time we're actually solving for sine C rather than being C. So if you're doing physics, pay attention because this is much more important because you need to find angles with sine law rather than side lengths. And so over here we know with the cross multiplication method that we do the opposite pair, which is sine A and C. And when we write our equation for sine C, we have sine A and C together as the numerator on top. So sine A multiplied by C. And then the last part of the equation, which is A, because we're solving for sine C, so we're not going to put that under here. We're going to put A under A. And I will just make a quick cut to sub in the values. Okay, here we have our equation. Now, the sine A was swapped in for 107 degrees. The side of C was swapped in for 15.9 because that's this side. And then A, the lowercase a, was swapped in for 36 because that is this side. And now, once again, we go to the calculator and we put in this equation. So we can go sine... Oh, hold on. It's not really... I'll just do a jump cut. Okay, here we have our equation. Sine 107, the 107 in complete brackets, so that we don't mess with the actual value inside the brackets, 107. And we multiply it by 15.9 and divide by 36, just like we see over here. And when we press equals, we get 0.422366794. Now, this is something that we must fix, because that is actually the value of sine C is equal to, 0.4, hold on, 4, 22, 2, 2, 2, 3, whatever. Okay, that's the value of sine c. Now, if we want to get the value of c on its own, then we will just clear the calculator, and we will go to our second function and go sine inverse sine, and then we will plug in the original equation of sine 107 times 15.9 over 37 centimeters. So I'm just going to cut to that. So here you see inverse sine of sine 107, and that is in brackets again, 107 times 15.9 divided by 36. See the same thing again, but with the sine inverse sine at the beginning. And then over here, when we press equal, we get 24.98, which rounds to 25. And if you remember, C equals 25 degrees. That was the original angle measurement. You can kind of see the 25 that I erased. But that was the original angle measurement. It's a little bit off because of rounding and all that. But yeah, that was the original angle, so we know we got it right. And that's how you use sine law for both a side length and an angle. But for physics, it is, well, we usually will use it for an angle rather than a side length. The next video is cosine law. That can also be used for angle and side length, but in physics, again, we are going to be mainly using it for side lengths, because sine law will be for angles, cosine law will be for side lengths. Basement Math Lab out.